Today's diving helmets are produced primarily for history buffs and divers performing underwater work, such as welding the submerged parts of bridges. Unlike a scuba tank, which carries a limited amount of oxygen, a helmet connects to an air pump at the surface, providing an unlimited air supply. A diving helmet is completely watertight, so the diver doesn't need a mouthpiece to breathe and can speak to people at the surface via a built-in transceiver. This helmet is the design the U.S. Navy used from 1916 until 1984. At the factory, they make the helmet's head portion, called the bonnet, from a copper sheet about 1.5 millimeters thick that's been spun on a lathe into a dome. They buff it smooth, then using a template, mark where to cut openings for the various components. It takes a good month and a half for the factory to machine all those components and assemble the helmet. With a hammer and punch, they dimple the copper at the marked spots. This will give the saw a foothold on the otherwise slippery surface. Then they apply cutting oil to prevent the saw from overheating as it bores through the metal. The first cut is a 6-inch wide hole at the front for the bonnet's hinged faceplate. They saw 8 openings for the bonnet's other components, including 3 windows. Next, with tin and lead solder, they fuse a threaded neck ring to the bottom edge. This ring attaches the bonnet to the helmet's breastplate, which bolts to the collar of the diver's dry suit. Then they solder a base to the faceplate opening. Like all the helmet's components, it's made of red brass, which is more durable than standard brass due to its higher copper content. Next, through a template, they drill holes into a banana-shaped brass exhaust tube. It enables the diver's exhaled air to exit the helmet. They solder the exhaust to the bonnet, positioning the non-perforated end over a hole near the diver's mouth and the perforated end at the rear. This directs air bubbles behind the diver, so as not to obstruct the view. Then they solder on the remaining components, including 3 window bases. Just as one does when installing a window in a building, they apply glazing to the faceplate and window bases to seal the 3-inch thick acrylic pane against leaks. For underwater safety, they screw a brass guard to the base. This prevents the pane from popping out should too much air pressure build up inside the helmet. Now they install the transceiver and feed its wires through a brass elbow, which will ultimately attach to a communications cable running to the surface. With the bonnet complete, it's time to shape the helmet's breastplate. They lay a copper sheet onto a breastplate-shaped mandrel, clamp on a breastplate-shaped form, heat the copper with a torch to make it malleable. Then, with a wooden mallet soaked in brine to keep it from splitting, pound the copper for about 45 minutes until it assumes the shape. Then they chisel out the neck opening. Once the copper has cooled, they transfer the breastplate to a form and begin reinforcing the bottom with a brass strap. After clamping the strap in position, they hammer the copper around and over its outer edge. Then they remove the clamps and solder the copper to the strap. Once the soldering's done, they grind the surface smooth and drill 12 holes into the strap for the custom-made bolts that connect the helmet to the collar of the diver's dry suit. Then, after flipping the breastplate upside down, they wrap solder around the bolts, drop them in the holes, and melt the solder to lock them in. They polish the metal and solder on the last breastplate components, a threaded neck ring for connecting the bonnet, and, at the front, a pair of brass eyes for lashing the air and communication hoses off to the side, so they won't get in the diver's way underwater. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.